Okay, for question 5, so part A1. Now, so because we assume that the system has unique solution, so as we know that a system will have unique solution if and only if the determinant should non-zero, the determinant of the coefficient matrix. So this is the coefficient matrix, and then you set it non-zero. Now, so first we simplify this one. So by the method, first we multiply all these three terms, so it becomes 1. And next is this 3 term, become 75. And the next one is this 3, so it is 6p. And then minus, you multiply this 3 term, minus 10. And then minus this 3 term, become plus 15, and then minus this 3 term become plus 3p. So this one is not equals 0. So after that, you simplify the expression. This will become 9p plus 81, not equals 0. So you get p is not equal to minus 9. So the part A, we want to find the range, so the range should be p less than minus 9 or p greater than minus 9. Okay, now for A2, if you want to find the values of the x, so by the Cramer's rule, x is the delta x over delta. So delta x is the determinant. Replace the coefficient of the x by the constant column, and the other all the same. And over the determinant is 9p plus 81. So again, you just explain it. This one become q plus 150 minus 12 minus 20 plus 15q, and then minus 6. So after that, we simplify it. You get it is equal to 16q plus 112 over 9 bracket p plus 9. So further simplify, it is something like this. Now for part B, we are assuming that E has infinite many solutions. So if this is the case, it means that the determinant, the delta, should be 0. So we get that P must be equal to minus 9. So under this assumption, E will become x plus 3y minus 2z equal to q, minus 9x minus y plus 5z equal to minus 2, and 5x minus 3y minus z equal to 10. So we can solve this one by the Gaussian elimination. So we look at the augmented matrix. 1 minus 9, 5, 3 minus 1 minus 3, and then 2, 5 minus 1 with the constant column q minus 2, 10. And the first step, we will multiply 9 times the row 1 plus row 2 put onto row 2. So the first column unchanged, and then the second column become 0, 26, negative 13, 9q minus 2. And similarly, we multiply minus 5 of row 1 plus row 3. Put onto row 3, so the answer become 0, minus 18, 9 and 10 minus 5q. And the next step is we further simplify the expression by multiplying the row 2 with the factor 18 over 26, add on to row 3. So the first two rows is unchanged. And the last one, this will become 0, and this one will become 0 again. And the last term, this term, it will change to 9q minus 2 times 18 over 26 plus 10 minus 5q. So after simplify, you get 16 over 13q plus 112 over 13. So in order it will have an infinite many solution, we will put the last number 16 over 13q plus 112 over 13 equals 0. So you can solve the q is equal to minus 7. Okay. Now with the q is equal, when q is minus 7, the e will become 1, 3 minus 2 minus 7, 0, 26, minus 13, minus 65, 0, 0, 0. Okay, so we can further simplify into something like this. Divide the row 2 by 1 over 13. So the solution is, I put the z equal to t. From the second equation, 2y minus t equal to minus 5. So y is t minus 5 over 2. And then from the first equation, x plus 3y minus 2z equal to minus 7. So you simplify, you get x is t plus 1 over 2. So the overall solution are t plus 1 over 2, t minus 5 over 2, and t, where t is any real number.